This is our Algebra 2 Module 6 test, and I'm going to go over all these problems, and we have some additional synthetic division problems, so that's where we are. Problem 1, choose true or false for each statement about the function f of x equals x cubed. And this is one of these things that you should just know. You have a polynomial function whose leading term has a degree, in this case of 3, which is an odd number. That signifies that we have an odd function, so the function is not even, it is odd. That's one of the things you should just know. There are definitions, but you should know that. The function is a negative where x is less than 0. And if you recall, and you can graph this quite easily on your calculator, the graph function looks like this, comes up, okay, y equals x cubed. And you can see where to the left of the y-axis, where x is less than 0, the value of the function is negative. C, end behavior. As f of x approaches positive infinity, x approaches negative infinity. Well, you can see here as x approaches infinity, y approaches infinity and not negative infinity, so this part C is false. D, the function is symmetric about the origin. And yes, what we have is 180-degree rotational symmetry. Okay, so that's what that didn't look exactly right about. Anyway, but that's it. So we have symmetry about the origin. Next, problem 2. Graph of x equals x cubed with 3 reference points is shown below. Does each of the following points represent a transformation of a reference point to a point on g of x equals negative 2 times quantity x minus 2 cubed minus 3? Choose yes or no. So what you have here is the standard form, or general form, is going to be a times quantity x minus h cubed plus k. And so the inflection point, or where this 0, 0, 0.0 comma 0 is translated to, is going to be the coordinate pair h comma k, very similar to what we've done for other types of functions. And so in this case, h is going to be 2, and k is going to be negative 3. So basically what we need to know is the point 0 comma 0 is going to, the input of 0 is going to translate to 2, and so the input of negative 1 is going to, you also add 2 to that, so you're going to get 1. 0 plus 2 equals 1, and then finally 1 will translate to 3. And basically you have 5 answer choices down here, and when you translate 3 points, you have only the possibility of 3 of these being yeses, and so at least 2 have to be no. And so in some of the problems here, some of the answers to the test, I saw all 5 of these marked yes. That's an impossibility, people. That's an impossibility. So really what we need to do is, if we just plug in 1, 2, and 3 as inputs, we are going to get the translated points of all these. Now, one way to do this, when you have a graphing calculator in hand, is in your function editor, just enter this function, and then if we go to our table view, we will see we will have 1 comma negative 1, 2 comma negative 3, and 3 comma negative 5. So 1 comma negative 1, 2 comma negative 3, 3 comma negative 5. So all of these are correct, these last three. And since the first two are, that's the maximum number of correct ones we can have. So these first two here, part A and part B, are no. Okay, let's go ahead to problem 3. Describe how the graph of g of x is related to the graph of fx equals x cubed. Again, the general form is going to be f of x equals a times quantity x minus h cubed plus k. And what we have is this x plus 2 in here, so h is going to be equal to negative 2, because to get x plus 2, we have to have x minus negative 2. So the way we would articulate this would be a translation, and there were other words too, translation 2 units to the left. Now some of you put down moves 2 units to the left, which is not as technically good of a term, but still articulates sufficiently the answer. Okay, here we have g of x equals negative 1/2 x cubed again. We have f of x equals a times quantity x minus h cubed plus k. What happens is this negative sign will reflect about the x-axis. So f of x is reflected about the x-axis, and I think it's in terms, is it not, of f of x? Yeah, reflected about x-axis, and this 1/2 is a vertical compression. Vertically compressed by a factor of 1/2. Now you possibly could have articulated these answers differently. 5, g of x equals quantity 4x cubed plus 3. In this case, the way the book had it, you would write this inside parentheses as a horizontal stretch or compression. What I like to do is you're going to have 4 cubed, because this cube outside here, x cubed plus 3. And this 4 cubed is going to be 4 times 4 times 4 will be 64 x cubed plus 3. So we will say f of x is vertically stretched, abbreviated there, by factor of 64, and translated two units up, or 3 units up. I had some students who would say translate it up, or they would actually tell what happened, but wouldn't quantify it verbally in English. Okay, you gotta be specific. Gotta be specific about this when you verbalize the algebraic symbology here. Okay. 6, a cubic function with general equation, g of x equals a times cos x minus h cubed plus k is graphed below. Uh, write a specific equation for g of x by identifying the values of parameters from the reference points shown. Basically, what you have is this is your inflection point. And the coordinates of that inflection point are going to be -2, 1. So basically, that is going to be our hk. So when we rewrite this function here, we're going to have f of x equals a, because we don't know that yet, times the quantity x, and we have minus -2, so we're going to put +2 here. And most of you did this quite well. And then outside we have +1. So what we have now is the inflection point, and we can use one of these other 2 points. And I'm going to use this first one here, -3, 5. So if we take this point here, -3, 5, we have the output here of 5 equals a, and we have x, which is -3, and then we have here +2 cubed plus 1. And now we can just go through the simplification here. We have 5 is equal to a, and -3 plus 1 is -1. So we're going to have -1 cubed, which is -1 times a plus 1, and subtract 1. So we have 4 is equal to -a, and so a is equal to -4. And so we can take this value of -4 that we've calculated and put it back in here. Let's see, here we go, right in here. And what we have here is f of x is equal to -4 times quantity x plus 2 cubed plus 1. So we will put this right here, f of x. And it seems like most of you got this one right. And to the extent you didn't get it exactly right, I gave some partial credit where feasible. So that's it. Next, we go to number 8. So we skip number 7. We're going right to number 8. Choose true or false for each statement about the function f of x equals -x to the 12th power. And the function is even. Okay, we have our exponent here, even. An even function will reflect about the y-axis. And when you graph this in the calculator, it looks like this. You have very steep, so it kind of flattens out like this against the x-axis and goes down like this. That's kind of what it will look like when graphed. And yes, function is even. The domain of the function is all real numbers, true for this and every polynomial function, that is true. The range of the function is -infinity, infinity. No, the range is only going to be, we're going to be greater than -infinity up to and including 0. So C is false. As x approaches infinity, f of x approaches infinity. No. As f of x approaches infinity, f of x approaches negative infinity. So this D would be false. Next, for 9 and 10, use a graph calculator to graph the function, then use the graph to determine the number of turning points and the number and type global local of any maximum or minimum values. So we have the factors here in factor form: x plus 2, x plus 1. Go to our graphing calculator. So we clear this: x, quantity x plus 2, quantity x plus 1, and we graph this in our calculator. And what we have is we are increasing all the way up to here and then decreasing for a short interval, then increasing. So we have 2 turning points. And each of these turning points have extrema that are local, because when you have an odd function like this, our range is going to be greater than negative infinity, so less than infinity. So there is going to be no global minimum or maximum. So our answers for this would be 2 turning points. If I could spell turning, that'd be nice. And we will have 1 local. It says, type local, but not global, maximum. And 1 local, but not global, minimum. So anyway, that's what you need there. Next, we're going to go to problem 10. So we have quantity x minus 1 cubed times quantity x plus 1. So we go here to our calculator. I'll just erase this. So minus 1 cubed, okay. Times quantity x plus 1. And so we graph the function here, and we only have 1 turning point, and we have 1 global minimum. So we come here, this is a start high, end high, even natured function. So 1 turning point. And 1 global minimum. Sometimes that's called absolute. So that would be it. Number 11, sketch the graph of f(x) equals negative x squared times quantity x plus 1 times quantity x minus 2. And basically, when you've had a graphing calculator in hand, you should be able to get this right. What I was looking for is the proper intercepts: start low, start high, whatever, or end high, whatever it is. But what you have is our zeros are going to be x is equal to 0. And since we have squared, that's going to be a multiplicity of 2. And then for x plus 1, we're going to have x plus 1 equals 0. So x equals negative 1. And our multiplicity of that 0 is going to be equal to 1. And finally, we're going to have x minus 2 equals 0. So we have x equals 2. So we have for this one also our multiplicity is equal to 1. And so when we multiply all these together, all these x's, we're going to have negative x to the fourth power. So it means we're going to start low and end low. And our we're going to mark our zeros we have at -1 and at 0 and at 2. So I've marked in blue here where the graph function is going to either touch or cross the x-axis. And we're going to start low and end low. So basically you're going to come up here from low to our 0 at -1. Then you ask yourself, what is the multiplicity? 1. That means we cross the x-axis. Then we're going to come down here to this 0 here. And that's what is the multiplicity of the x equals 0, 0? It is 2. So we're going to bounce here. Then we're going to come up here and hit our last 0 at x equals 2. And is this an odd or even number multiplicity? It's an odd number multiplicity, so we're going to cross the x-axis. So basically, when I'm looking for a sketch, I want to see the definitely at these zeros if we touched or crossed the x-axis and what happened. I wasn't looking for perfection, but enough to show the understanding. But it shouldn't have been a hard problem at all with calculator in hand. 12. Determine if the sketch shown below could be the graph of each of the following functions. Choose yes or no. Well, basically, what you have to have is the thing is going to be odd, negative, and so you're going to have 3, yeah. So you can basically graph these in the calculator and see which ones are going to fit the bill. That's all it's going to be. And I'll just go ahead and put these in a calculator. We have, well, first of all, look at A. You have this x equals 4 as a 0, but that's a double 0. So this is only going to touch but not cross the x-axis at x equals 4. But at x equals 4, we actually cross the x-axis, so A cannot be right. If you look at the, this one could be, this last one. Looks like it could be right because you have x equals, well, this is going to be x equals, you have this 0 here, x equals 1. Or x plus 1 x plus 1 equals 0. So we're going to have x equals -1 as a 0, but we have a 0 at +1 here. So D is not correct either. So these two are incorrect. And what's going to happen is these middle ones here are correct. Now, you don't have a scale obviously on these. It's just these have the same factors, but they're mixed up. You don't have a scale on the y relief, and so you can't tell between those two what they are, the amplitude, what that looks like. But we know that the form of where the zeros are is correct. We have x, in the case of C, x minus 1 is equal to 0. So x is equal to 1. Check. We have x plus 4 is equal to 0. So x equals -4. Check. And finally, we have x minus 4 is equal to 0. So we have x is equal to 4. And we can see that that's what all those zeros are. If we do for part B, we'll have similarly the correct zeros with their correct multiplicities. So B and C are yes. Next, 13, an x by x square is cut from each corner of a rectangular sheet of cardboard. So we went over this, I thought, quite well. And basically, if what you have here is you have a sheet of cardboard here, and you're going to be cutting corners, and you're going to your dimensions of the corner are going to be x, and each of these corners is an x by x square, and the width of the box is 13 inches, and the length of the box is 17 inches, and so your function that will work for this is f of x equals x, which is the height, times 17 minus 2x times quantity 13 minus 2x. And if you happen to get the right function here but didn't make the proper analysis from here, you'd still get credit for it. I want to show you now graphing this in the calculator. We go to we have x times quantity 17 minus 2x and times quantity 13 minus 2x. And when we graph this function, we don't see a whole lot. And I'm just going to go to the window, make it what a window could be for this. And I know I'm working from understanding, having worked it in the past. So we go to graph, and basically we're looking for the x value of this maximum here. Well, there are different ways we can do this. One thing we can do is when we look at the problem, it says to the nearest tenth. So one way to do this is just with the calculator. If we go to table set, and we can start at 0, but we can go ahead and put delta table 0.1 or tenth. That's the nearest tenth. And we go to table view from here, we can see wherever this y value is the greatest, that is going to be the proper tenth of inches value. So you come up here, getting bigger, bigger on the right here, still getting bigger. And then when we get to 2.3, 2.4 is the maximum, 240.1, and then the value function starts going down after that. So the correct answer to this will be 2.4. And then if you want to see this in the graph, you can go to second trace and get maximum 4, and it says left bound here. So we go to the left of the maximum, press enter. Now it says right bound, so we scroll over to the right of the maximum, press enter, and enter one last time, 2.43. So 2.4, we'd say x approximately 2.4 inches. So x is approximately 2.4 inches. And if you go ahead and you said equals 2.4 inches, that's going to be correct also. Okay, 14. We have 3 zeros here. We have x is equal to -1. We have x is equal to 2. And we have finally x is equal to 3. And to find what the zeros are, we solve one side for 0. So if we add 1 to both sides, we have x plus 1 is equal to 0. So that's going to be one of our factors. Then for this x equals 2, if we subtract 2, we have x minus 2 equals 0. And finally, for x equals 3, if we subtract 3, we have x minus 3 equals 0. Now multiplicities. Okay, we have this first 0 of negative 1, well, we bounce off the x-axis. So this is going to be multiplicity is equal to 2. And then this other two zeros will be multiplicity equal to 1. And then the last 0 at x equals 3, multiplicity equals 1. So our function is going to be f of x is equal to, I'm going to put this x plus 1, and with multiplicity of 2 we put squared out here, and then we have x times quantity x minus 2 with multiplicity of 1, nothing squared, and then we have times quantity x minus 3. And then we can verify by going to our function editor and put quantity x plus 1 squared times quantity x minus 2 times quantity x minus 3. And we're going to see, we can't see very well. I'm going to have to go to standard window and zoom 6. So that's what it is. And we can, one thing you can do with these is adjust to the dimensions of the graph. If you go to the problem here, you see x minimum negative 4, x maximum positive 4, and then you have these other values. Maybe y is from negative 5 to 5. So you go to the window view. We can just change this to negative 5, 5. And for y minimum, negative 5, y maximum, positive 5. The scale is not given on the graph there. Yeah, so the scale is not exactly the same, but the zeros are the same. And that's the important thing. If we want to get the scale more correct, we might do like negative 10 to 10. I'm not sure exactly what it is. And then just, yeah, so that looks more accurate. Anyway, that's going to be it. Now, the last problems we're going to have here are these synthetic division problems. And we go right here. For polynomial division, x minus 3 into 4x cubed minus 5x plus 2, we have 4x cubed plus 0x squared minus 5x plus 2, and our 0 is equal to 3. So it's going to be x equals 3 is our 0. So 3 will go on the outside, not negative 3. And we're going to have 4, 0, negative 5, 2. So D is our correct answer for 15. For 16, if we have 3x cubed plus 4x squared minus x, 1x, plus 5, and we have x minus 2 as the divisor, that means our 0 value is going to be 2. We can just work it out this way. Bring down to 3. 2 times 3 is 6. 4 plus 6 is 10. 2 times 10 is 20. Negative 1 plus 20 is 19. 2 times 19 is 38. 38 plus 5 is 43. So that will be our remainder. B is our correct answer. 17, for a dividend of 2x to the fourth power plus 5x cubed minus 8x squared minus 17x minus 6, which divisor will result in a remainder of 0? There are different ways to do this. I'm just going to come clean, and I think A is going to be our correct answer. And you can try different ones. You can use the remainder or factor remainder theorem. So we put 2x to the fourth plus 5x cubed minus 8x squared minus 17x minus 6. We just bring these down. We have 2x cubed. Negative 1 times 2 is going to be negative 2. 5 plus negative 2 is 3. Negative 1 times 3 is negative 3. Negative 8 plus negative 3 is negative 11. Negative 1 times negative 11 is 11. Negative 17 plus 17 is negative 6. Negative 1 times negative 6 is 6. And so we have a remainder of 0. So A is our correct answer. The last one, what is 2x to the fourth power plus x cubed minus 6x squared plus 2x minus 6? Not a multiple choice answer situation. So we're going to break this down using synthetic division. We have 2x to the fourth power plus 1x cubed minus 6x squared plus 2x minus 6. And then our 0 is going to be 1 because we have x minus 1 is equal to 0. X is equal to 1. So 1 is the value we put on the outside. Bring down the 2. So we have 2. And so our answer is going to be 2. Start with 2x cubed. And then 1 times 2 is 2. 1 plus 2 is 3. So we have plus 3x squared. And then 1 times 3 is 3. Negative 6 plus 3 is negative 3. And so we're going to have minus 3x. And then we have 1 times negative 3 is negative 3. 2 plus negative 3 is negative 1. So we're going to have minus 1. And finally, 1 times negative 1 is negative 1. We have negative 7. And then we're going to have finally minus 7 over our divisor of x minus 1. Now, a lot of people, some people, I don't want to say a lot of people, some people made minor mistakes on this, and if I saw just one little arithmetic thing, and if you made one little arithmetic mistake, I took very little off for this. Well, this has been the whole test. Good luck. I hope you learned something from this. Good luck, and thanks for viewing.